main feed, which is there. I'm almost there, Spurs. I've always got it. And oh, I heard myself then. Have we got a yeah, I think that's an echo. Have you got, yeah, I don't suppose you've got headphones, have you? Yeah, it's quite a significant echo, that, actually. Unless we are now actually live.
Was that a really loud pop? Was that a really loud pop?
Right, and there we go. And I have absolutely no idea how much of that you heard. So let's just see in the chat how much of me faffing about there. Did we actually go live there for a bit when I was trying to sort Chemo's icon out? Or did we not? Let's have a look. In fact, do I call you Spurs now or do I call you Under No Pressure?
You can call me Chemo, call me Spurs, call me No Pressure. I think most people will know Chemo or, Spurs, Chemo.
I just want to say a massive thank. I've had 2 super chats in already, and JL Truth, thank you very, very much. FTFE. I will read this out now before we start. It says, warning, legal notice, any debate involving, sorry Spurs, but I've got to read what comes in. Any debate involving Spurs requires face palm protection to be applied. Agree to disagree, take no responsibility for injuries from face palms or other incredulous injuries. So that's for you, that one, Spurs. Right, can people in the chat hear me? Because I had a complete mess before when I was trying to set this up, and I don't know what you saw and what you didn't. So I've still not had anybody saying that they can hear me. Maybe there's a little bit of a loud and clear, brilliant. Thanks, Pete 70. So tonight happened because I was in touch with so one of my favourite people on YouTube got in touch with me yesterday. Someone I've got like this much respect for got in touch with me on YouTube yesterday, and that's the man who is currently sat to my left or right, which is AB Science. He got in touch with me saying that Spurskimo, or Under No Pressure, as his new channel is, has been in contact and wanted somewhere to throw some ideas around. So I don't know exactly what the theme for the night is. What I'm going to do is I'm going to pass you over to AB Science just to say, whatever, introduce himself, shill his channel out. Spurs can do the same, and then we'll get into the nitty gritty of it. Thank you, Sarcastic Barmer, for that super chat. We'll go AB Science. You got to support their AB Science and Nerd Angle again. lots of people looking forward to hearing what you've got to say. So very, very much looking forward to hearing you, AB Science. So, AB, do you want to introduce yourself, shill your channel out? Seems like people know you anyway.
Yeah, for those who don't know me, well, I go by the name of AB Science on YouTube. I'm a physicist and I talk stuff on YouTube. I make videos about, well, I started mainly on flat Earth, but I'm looking at, other topics as well. And it's all kind of under the guise of debunking with kind of scare quotes, because that's not actually the purpose of the channel. The purpose is just to explore interesting ideas in science, mainly physics, because that's my jam. But yeah, that's what I do. And well, we're here tonight, as Catz said, because Spurs contacted me. Just wanted to talk a bit about science in general tonight.
Fantastic. And I'll pass you over to Spurs. Just Sarcastic Barman was one of the super chatters before. If anyone's not caught his debate from last night, it was his first debate and he did extremely well, I thought. So that's well worth the watch. That's on the channel. I'll not spoil it, but Sarcastic Barman, if you don't know him, it's well worth the subscription as well. He smashed it last night, I thought. Spurs, or Under No Pressure, it's your time to shine, mate. Shield yourself out. Tell us all about your channel.
Yeah, as you said, I'm Spurskimo. I'm a researcher. I look into the natural and physical world. And obviously a couple of years ago, several years ago now, we're talking 6, 7 plus, I understood the Earth is not what we were told. And so I set about looking for the science to verify that the Earth is actually, what they told us, which is a globe spinning, flying through space. So ever since I heard that this idea that the Earth is not a globe, I've just spent night and day basically hunting down the professionals, hunting down the experts, politely, of course, just asking them to explain the physical, the natural world around us, and how we know what we know. So yeah, I've got a channel, Under No Pressure, where I just hold discussions, debates with just general people about the reality of where we live. So yeah, that's pretty much that.
Well, there we go. Subscribe to Under No Pressure. There's Spurskimo. Links for both these will be in the description later on. Now, with this being so last minute, I'm not even sure what the topic of conversation is going to be. I'm generally just going to sit back and listen for the bulk of this, because I think it's more of something you've organised between yourselves and you just wanted a platform to host it, wasn't it, really? So if I pass it over to you, AB, and you can kick things off and we'll just see where we go from there.
Well, and I'll take that and pass that over to Spurs. Really, I'll let him set the pace and the agenda. Any questions that you have, fire away.
Thank you very much. So obviously, the idea is that we live on a spherical object, and we have other objects that are seemingly attached to that other object. So to me, this would be a natural phenomenon in nature that would need answering. So we can take gravity, why things fall. People tell us there is a force, there's an attractive force, but yet on my quest, I'm yet to find a scientific way of validating this force of gravity, or any way of verifying that there is an attraction. So before we kick off, gravity, how do you understand gravity? Is it a force? Is it not a force? What's the scientific understanding of that?
Well, so I'll preface this with I'm not an astrophysicist or a cosmologist or stuff like that. I deal with the really small rather than the really big, right? So I'll start off straight away and say that this is not my area of expertise, but from my understanding, gravity is not necessarily a force in the kind of classical sense. It is something called an inertial force, right? And this is a force that appears to be acting on you by virtue of you choosing a reference frame which is accelerating. So one example of this that you will be familiar with is the centrifugal force, for example. That is, if you are, say, in a car going around a roundabout, you feel a force going, pushing you to the far side of that, pushing you out of the roundabout, right? You feel that if you go around a turn when you're in the car, right? And that is one of those forces that pops up. What's actually happening is that if you were an observer on, say, the side of the road, actually what's happening is that there's a force applied towards the center of the roundabout. And that's what we call centripetal force.
Okay.
But because of your choice of reference frame, and if you are treating you in the car as if it were an inertial reference frame, even though it's accelerating, right? It's changing direction. That gives rise to the centrifugal force. So, in that same sense, and that's kind of the key point, what Einstein did is just think about, well, can we tell the difference whether there's a force acting on us or whether we are just accelerating upwards?
Okay.
Right? And in the only situation where you don't have forces acting upon you, where you don't feel those forces acting upon you, is if you were in a free fall, in a vacuum, say. So you were somewhere out in space, right? You have no sensation or whatever to tell you that there is a force acting on you. You're in free fall. And then the basic line is that we cannot tell if we on the surface of the Earth are in an inertial reference frame or in free fall, and something is stopping us. And that essentially gives rise to that force. It's because we are treating our reference frame as we're on the surface of the Earth as if it is an inertial reference frame, but within the context of general relativity, it's not. It's actually an accelerated frame. And that is why we feel a force.
Okay. So you're saying that there is an actual attractive force?
There is. So if we're treating it from our reference frame, we would see that as an attractive force, right? So if we were to say, well, we stand on the Earth, we pick something up, we treat our reference frame as an inertial reference frame, we drop something and it lands on the ground, right?
Sure.
But from my understanding, and I must really preface this, by no means, I mean, I didn't even, I actively avoided any astronomy or astrophysics when I did my training, so I could focus on the small stuff. But then within the confines of general relativity, the object that's dropping and accelerating towards the Earth, that object reference frame would be the correct one. However, that is not a particularly useful framing for our everyday kind of life.
Okay, so I mean, again, we're just looking for why things fall, right? I mean, science should be able to answer this kind of phenomenon in nature, right? Something falls, why did it happen? What's the cause? It's very simple. So I think what you're telling me is the presupposition that, if the Earth were a ball and it were such a large mass and it were in space, then it would bend the fabric, it would cause things to appear to attract towards a larger mass, I mean, that's understood. That's fine. But testing that in science is another question, right? Because obviously this is the hypothesis where you're saying, well, I understand that mass will cause or give the appearance of a force, right?
Yeah.
Yeah. But I mean, we can only go with that if there is an experiment. Would you not agree?
Yeah, we can do experiments.
Well, that's it, right? So if we don't have an experiment to obviously test our hypothesis, our predicted cause, you agree?
Well, it depends on what limits you want to apply. To what you can investigate, right? Because I think Richard Feynman put it very elegantly and very quickly, right? How to develop a theory. First, you guess. And
that's not quite right, but go ahead.
It is. You guess, right?
No, you start with observation, but...
Yeah, but you guess why that observation, what drives that, right? What you're observing. Simple as that. You make a guess and you compute the consequences of that guess, right? So, for example, I can say, well, let's just take gravity, right? We compute the consequences for that guess, and we find that the velocity squared of an object the instant before it hits the ground is proportional to that gravitational acceleration constant, 9.81 meters per second, and the height, right? So we've just got that.
Yeah, okay.
Okay. And that is a consequence of that guess. Let's just say that is the consequence of the guess. All right. And then you test it.
You tested your formula?
Yeah.
Well, so what was the cause then? What was the cause of things falling? What did you find?
We just say that, within a Newtonian framework, mass attracts mass. It's, there's just some force, right? Newton doesn't talk about a cause for that force, right? It just says...
Hold on. How do we know it is a force if we don't know if that's the cause?
Well, that is a good question, right? That is a good question, because how do we know it's a force? Well, we define force as the product of mass and acceleration, right? That's the definition of force.
Yeah, but when something falls, we know what caused the acceleration. Again, this is quite simple. I think you're introducing an extra alternative without actually testing it. So if you throw something, you've moved it out of its equilibrium. It's now in disequilibrium. It's now falling until it finds its equilibrium without the force. So I don't see, I mean, this can be tested as well. We can control the direction, left, right, up, down, any which way you like, depending on the density, you see?
Well, before we go into the details, right, we have to establish, right, that we define something as a force, right? And we define this thing, the product of mass and acceleration. We'll take that as a definition. It's not the most useful one, but mass times acceleration. We define that as a force. So we have an object,
okay,
and according to our definition, a force is being applied onto that object.
Okay.
Right? And that is just the basic framework.
Why do you call it gravity, though? I mean, again, if the object's on the ground,
yeah,
and I pick it up, I am the cause of why it fell, right? I mean, when it falls back to the ground, it hasn't found its equilibrium, has it? It's just on the surface that's below where I dropped it. So obviously, if you were to remove the ground from that object, it would fall until it's found its equilibrium. So again, there's no force required here.
Well, yes, because the definition of force is it accelerates, right? That is just a definition.
Yeah, but whether it's a definition, what we can see in reality is that we know the cause, the force. So what you're doing, you're replacing my force that I've created and saying, well, you didn't create the force, something else created the force.
No, we are simply establishing that there exists a force.
Yeah, me.
Okay.
I created the force.
Okay, but you're getting bogged down in details that are aside from the point, because you asked the question, how can we validate? How can we validate a theory, right? How can we do an experiment to validate a theory? So, as I said, with this equation, right, this makes no assumption about the cause of the force, right?
Yeah, but is there a force? That's the question. You're saying there's a force, an additional force. This is what I'm questioning now. This is why I research these things, because I'm not saying you, but guys like you, scientists, so-called scientists, however you want to put it. I'm not trying to be rude, but they say this equation is the force. When I'm saying, well, the apple that fell from the tree obviously became too dense for the medium that it was in. It grew, got larger, too weak for the stalk, and then it fell to the ground. And the only reason why it stopped falling was because of the ground. Obviously, if the ground wasn't there, it would fall until it's found its equilibrium. So if it fell on water, for example, it may have floated, you see? Again, no force is required.
Well, what's causing it to fall?
What caused it to fall? What, from the tree?
I mean, is there a force that is causing it to fall?
No, it fell because the medium that it was in could not support it. It became too dense. So on water, it's not going to fall through the water, right?
Right, but what I'm trying to establish, right, is there is a definition for force, right? Mass times acceleration.
I'm not arguing that. We know there's a force.
So if something is falling, there must be a force acting on it.
Yeah, so we know what the force in this case. So the tree started to grow, it left the ground. The apple was in disequilibrium and was trying to return to equilibrium, and that was the cause. The cause is the density here, the disequilibrium that's going on.
So, because I don't want this to kind of be a debate, but what? So, how would you test the density being the cause?
Oh, well, you would take, let's say, for example, the apple fell into water, and you had two bodies of water, one with salt, one without salt. For example, this is an example. In nature, we're walking along, two lakes, one side water and salt, one side fresh water, no salt. We see the apple fall, we see one float, we see one sink. We want to know what the cause is. We can predict that the salt made the water dense, yes, causing it not to sink, not to fall. So we can test that. We can just take an egg, an apple, an orange, a potato, and just make the medium, which would be water, more dense or less dense. Again, no force required here. Because remember, let's say let's take the egg, for example. We've got the egg, egg's in the bottom of the glass. It's just sitting there. We pour salt into the glass. The salt will apply pressure to the egg from the bottom, causing the egg to rise, because obviously force, you need pressure, and this will cause the movement that we have here. Again, no other force, fictitious force is involved here.
Okay, so sorry, I got that the wrong way around. Sorry.
I've just seen a question in the chat just while you're doing that. Is it right? We've just posed one from
Yeah, go for it.
I forget who said it. Maybe someone to scroll and find it. But Spurs, somebody's asked, when you said that the salt makes the water denser, we were altering the density when we add the salt. They've asked, how do you know that the water becomes more dense when you add the salt? How do you know that?
How do you know the water is more dense?
It's a two-part question. The first one is, how do you know that the water's become more dense? And what's your answer to that?
Well, again, you could you can see movement with the object. That would be one reason why we know. Another reason, if you wanted to be more technical, you could take a device. You could test the parts per million. You could find out the density beforehand, and then obviously find out afterwards.
Because the second part of the question was that we know that salt or dissolving anything inside a liquid makes it more dense because of previous research and previous study. So science is a little bit more complicated because we do build upon things that we've learned in the past. I think that's the point they were making. Anyway, this isn't my debate. They were the questions I've read, so I will disappear. Sorry, AB, back to you. Thank you, End Flat Earth. He's just said, why did Flatsoy delete 11 frames chemo? I don't know what that means. I'll pass that back to you. What's 11 frames chemo, and why did Flatsoy delete it?
This makes me laugh, this question. So, I mean, I've cleared this up several years ago, a couple of years ago on Red. So obviously Red posted a video with a launch, and part of the rocket fell down beyond the horizon, revealing what was beyond the horizon. I passed this video over to the Flat Earth community. Flatsoid edited it in some way, it appears, and there was slight confusion over whether Flatsoid was me, but obviously Flatsoid came forward and said, yeah, it was his video. You can go and check out Flatsoid. He's a Flat Earth researcher also. But yeah, the 11 frames, I think Flatsoid was just trying to make a point relating to the horizon there. So yeah, that's that.
Cool, thank you very much. AB, back to you, mate.
Okay, so you talked about varying densities, right? And then, you vary the density of the medium and you experience a different force. Let's say we attach the we attach the object to a spring balance so we can measure the force acting on it, right? The net force, the net downward force or upwards, right? So if it's going up, well, if it's completely out of equilibrium, you would measure 0. Right, and when it sinks, you would measure some force, right?
Well, okay. So you've got the object, the spring. You got the weight hanging. Again, the object is not in equilibrium. So it's not that there's a force acting on it. It's just that it's in disequilibrium. So if you put the object in a different medium, it will not give you that same measurement therein, right?
Right. So it's you vary the density of the medium, right? And the force on the object changes.
The force? What force?
Well, let's say it sinks, right? We've got an object which is definitely denser than the medium, right? As long as it's denser than the medium, it will sink, but it will sink at a different rate. Okay,
yeah,
we can observe that.
What force is that?
Huh? It's completely irrelevant what that force is right now, right? Because you said density is a factor in this system, right? We vary density, right? And we can measure the weight of that object in the medium.
Okay.
Right? So That's fine. We can figure out, okay, in this system where we've got an object which is submerged in some medium, the apparent weight of that object changes as a function of density. Now, okay, great. So have we got our final answer, or are there more questions we can ask here?
Well, what other questions? What else are you hypothesizing about when we have our predicted cause to the effect?
Well, because if I change the volume, for example, right? Because you're talking about the density of the object. There's a factor as well, is that not?
The density?
The density of the object, is that a factor as well?
Yeah, I mean, it's relative, whether it's the object. Have you seen the density tower?
Yeah, I've seen the density tower. But the point is, right, so density is a function of two variables.
Okay.
Right? We can, density is mass divided by volume.
Okay.
So, and we can establish that the density of the object, just from observation, right, that the density of the object clearly has an effect, right? I have an egg in salt water that seems to float, but I can take an equal-sized egg made out of lead, and that's going to sink.
Sure.
Right? So we can establish.
Remember, it's relative. So if we change the medium there.
Yeah. Okay. That's fine, because we can perform lots of measurements for the medium, right? Mm-hmm. So we've established that we can change that force by changing the density of the medium. Fine. Okay, so now we move on to our next variable. We hold the density of the medium constant, right? And then we start changing the density of the object.
Okay.
Right? And we can change the mass of the object whilst keeping the volume constant, for example. And when we do that, we get different rates, different forces.
Not different forces. What do you mean different forces?
Well, we're hanging something from a spring balance, right? So, I mean, let me just grab a black pen, right? So, we've just got a beaker. We draw a spring balance, right? Right, so we've just got a beaker with a beaker, and there's a spring balance with an object suspended, right? And we make sure that it's the blue line indicates the medium's level. It's completely submerged, right? It's going to sink. Now, this spring balance is going to measure the force, the downward force acting on it. Right? It doesn't matter whether it's gravity or density, buoyancy. Right now, it doesn't matter. We are just looking to quantify this force.
Are you presupposing this force here, right?
Well, we observe that there's a force, right? It sinks.
Because of the medium, yes, that it said.
It doesn't really matter at this point what the mechanism is for that force. We're just trying to quantify it. Okay? We're trying to figure out a little bit more about this situation. So we can vary the mass of the object whilst keeping the volume constant.
No. I mean, I think gravity was only to explain, why objects are on the Earth on a ball, because people would ask questions. If you're going to tell somebody that the Earth is a spherical object, because you've already presupposed that, so people will say, well, if it is a spherical object, how are people staying on underneath us? I think you would obviously say, direction. There is no direction in space. It's all relative. Everything is pointing towards the center of that mass. But then obviously you'd have to demonstrate, because this is all based on an if this, then that, right? So what you're doing is explaining something that already has an answer, and you're introducing something that's not observed. No. So obviously when things fall, they fall for a reason. They fall for a cause. And 10 times out of 10, science, this method will tell you why that thing fell. We can never not tell you why something didn't fall. So rain, water goes up from the ocean, condensation forms clouds, the water becomes too dense for the medium that it's in, and it falls back down. You see, and when it's in a smaller form, when it's less dense, when it's lighter, it goes up. You see, so the direction of anything can be controlled like this. You can take a balloon and have it sit in the middle of the room. No force is acting on it whatsoever. Okay, and this can be controlled. So we can control the movement of objects. And if we were to make that room more dense, either side, left or right, well, what do you think would happen? It would move accordingly, right? Again, no other forces than what we've introduced or than the density and the medium that it's in.
Right. So you see, the problem is that what you're doing right now is you're taking, right, okay, I've taken an object, I've submerged it in a medium, I vary the density, and I vary the density, and depending on the density, it sinks or floats, right? And that's fine. That's that is definitely a variable in that equation. But then you stop asking questions.
What are the questions? If we have the cause to any effect in nature, in the natural physical world, why would we look for another reason unless there's like an agenda, I would say? So, like I said, how I understand gravity was only introduced to explain things sticking to objects that are spherical. So how does that happen?
Spurs, sorry guys, can I just interject? It's not that I want to take part, but some people are super chatting some questions here, and I think this is a good time for one of the questions that someone super chatted. And this was B-Ball for Life, and it was also posted on the community tab. And they've said, why? So, Kimo, you brought up the density tower, yeah?
Mm-hmm. Yes.
Why do they not work in free fall? Why do they not separate into different densities when they're falling? To discuss that, and Sarcastic Barman as well has also asked, do you know the formula for buoyancy? But start with the density tower one, because I think that fits in with what you were saying, and I'll just disappear again.
So what's the question? In free fall, what happens there? What's the question here?
So if you've got a density tower, imagine you take that density tower onto the vomit comet, the plane that...
Yeah.
When it starts to fall, the layers of different density will separate out. Sorry, not separate. They will start to mix. They will no longer be separated out by density. It doesn't work.
I think that's questionable here, Catz. I've seen the one on the vomit comet, and I think the flat earthers, the community is saying that he shook the container. So that would need multiple examples of people going up into vomit comets and showing that the liquids there do actually mix without the guy shaking it with his hand, right?
Actually, I've done it myself. In school, we do it with the kids. You take a little bit of oil, you put it on top of some water in a test tube, you hold it, you film it with a mobile phone, you drop the test tube with the oil and water, and they show the same effect. So it's something like we do with the kids at school. I just wanted to pass that on, but it's not my debate or discussion. So that's my question done. You guys carry on with it. I'm ducking out. But remember, Sarcastic Barman has asked equation for buoyancy as well. I think I know why he said that. Maybe AB Science will tell us why he said that. I think I know, but I'm going to.
I understand why he said it. The unit for buoyancy, like other forces, is the Newton buoyancy force, density of liquid, gravitational acceleration, volume of liquid, density, gravitational acceleration, height of liquid, surface area of object, and the buoyant force of liquid acting on an object. But this is the thing, you see, you guys are already including gravity. This is the problem. This is one of the biggest problems, that you include a force that hasn't been validated. So you're saying we don't need to know the cause, we're not interested, we're just going to presuppose there is and assume that there's a force, and then we can now apply other things on top of that, just because we have that idea. So yeah, that would be the buoyancy force there, but I don't see why it's relevant to the point here.
Well, the reason why it's relevant, and that's the reason why I'm asking, is like, well, what if you change the mass or you change the volume of your objects? And you're refusing to go into that. But the reason why people would refuse to go into is because they would end up with this equation. Right? That is the equation that describes the system. Now, I've been generous and just labeled that as 9.81, and then, okay, sorry, people, meters per second squared, right? That is the equation that describes the system. Now, we can explain what density has to do with it. We can explain what volume has to do with it. We can explain what mass has to do with it. But you still need to figure out where this 9.81 meters per second squared comes from. And that is the issue. Because there appears to be another factor. There appears to be it's either a constant or, you know, it could be a universal constant for all we know, just from this experiment. But it is there, and what is it? And we would like to know more about it.
Okay,
And,
so, I mean, you want so you want to go with the pulling force, the attractive force of gravity. How does that work? How do you apply pressure in a pull?
sorry?
So you say, is gravity a push or a pull?
That's a nonsense question.
Now, what does gravity? Does it pull the object towards the Earth or push it towards the Earth?
Well, the gravitational force means that two objects tend to move towards the mutual center of mass.
Is that pull or push?
A pull or push is meaningless.
Well, what do you mean? We can only move objects with pressure, right? We push something, you apply pressure, with force. Force, you apply pressure. So you're saying there's no pressure with this force.
Well, the words push and pull are meaningless.
I don't understand what you mean. So what is happening? We're describing what is happening with the objects. They're being pulled or pushed.
Right? They accelerate towards each other.
Yeah, how?
Well, that is a key question, right?
No, it's not. I mean, you're talking about something that we do not know about. We've never seen or experienced what you're describing. Just think.
And this is why I went earlier, right? In the process of science, we observe something and we make a guess as to what explains that observation. We compute the consequences of that guess and we test that with experiment. So a fine example of a guess would be Einstein postulating bendy space-time. And he delivers a beautiful set of equations that is able to describe everything we have seen so far, plus it addresses one anomaly that we've observed.
Why are you answering me in kind of mathematical terms and not scientific? I mean, are you saying...
Because mathematics is an integral part of science.
Yeah, but are you saying maths can cause something to happen?
No, he uses maths to describe something. So he has a description, right?
Yeah, that's fine. Okay, so you're describing something. But what about actually practically demonstrate it? Does science do that?
Huh? Well, you
practically demonstrate the force.
Right. So, if you can not interrupt me for a moment, what I'm saying is we compute the consequence. So Einstein formulates this framework, right? That describes everything we have observed, and it holds with the understanding at the time of the universe. Plus, it is able to explain one little discrepancy. Now, that's fine, but that does not make a good theory, right? What a good theory then does, it provides additional predictions. And these are the consequences that I talked about, right? Because it's fine, you have an explanation, it's internally consistent, it's consistent with observations, that's fine. But we can't really tell if it's just magic hocus pocus or not, right? What we need to do is find a new hypothesis that we can test or predict something new. And one of the key things then that it predicts was gravitational lensing, which was then observed, right? It predicts gravitational waves, which were observed, right? And that is how you validate a theory, right?
Again, what you're doing is validating your own presupposed mathematical equations, because you're not actually going out there and validating the force. I mean, that force is the key to your entire paradigm here. I mean, if you don't have gravity, everything that you've kind of done, you've studied, kind of falls apart. And
Right,
I think that's what you're up against. And if we can't demonstrate the force, well, is it science if we don't have an experiment?
This equation is a logical conclusion, right? It's an indisputable logical conclusion that the theory predicts.
Isn't that your concept, though?
Huh?
Isn't that your concept? Isn't it your idea, your concept?
I can figure this equation out experimentally, right? You can take two approaches, right? You can do an experiment, you observe something, and you start fiddling with different variables, you start changing bits around, and then you can create an empirical description, right? And that's fine, that has value. Or you can take the other approach, and you can take a first principles approach. So from first principles, we've got, all right, okay, so we start with the first principle of F equals NMA, right? And we start pushing a ball on the water, and we feel an upward force, and it's like, oh, there's a thing happening. And when we follow that thought through logically, then we end up with this equation. And then we can test that, right? Because this is the logical conclusion of the initial statement.
Yeah, but you're going against what we see and observe logically. So
no.
Well, of course you are. You're saying that there is a force that's dictating and controlling objects, when in reality we know that if things fall, we know what caused that. So you're taking away what we observe in the natural, real, physical world, and saying, well, we're going to change, what you're observing. It's not you who caused it to fall, or the tree, the growth, the medium. We're going to say it's something else just because we say so.
Well, if you do this, right, and experimentally verify this, you cannot conclude that density is the only thing that does it. It's just, you cannot conclude that.
If you're on a board, yeah, I mean, of course, you would say there's something else going on. But if the Earth is flat, stationary...
No, even if it were flat and stationary, there must be something else going on, because there is one constant in there which is doing something, right? And there's one constant there, and if you do the dimensional analysis, it shows that that's an acceleration.
But when an object is in balance, in equilibrium, there are no forces acting on it whatsoever, right?
Well, there are two forces acting on it, but they're equally balanced, so they cancel out.
Okay, how are you measuring, how are you discovering those forces when it's in equilibrium?
We can vary the variables. We can do a series of controlled experiments to validate every part of this equation until there is one value that comes out, and that's 9.81 meters per second squared, right?
Okay, so let's do it then. So we've got the egg. The egg is now in equilibrium.
Yeah.
Okay, so where are the forces acting on it?
Well, you just increase the density to figure out. You measure the volume, so you measure the mass, and you do that for different eggs.
So that's what I mean. You're going to increase the density and create the force. So you've just said it. You've just done it. We've just done science. We've tested our predicted cause, which was density, and you said you're going to manipulate that and give us the effect that we were looking for.
No, it's a factor. It's a factor.
No, because remember, our hypothesis is the predicted cause. That's all we're
It doesn't matter it doesn't matter whether your hypothesis predicts a force or whether it says it's a factor, right? If it is the only cause or it's a factor, it would be absolutely silly to suggest that you can't. Okay, I hypothesize this. So if I find that, right? So if A, then B, right? And you observe B, then it would be silly to conclude that A is definitely the cause, right?
Well, we don't
that you've
know that.
proven that A is the cause.
Yeah, but look, how are you going to form a conclusion unless you test it? So let's say you see the egg rising. It's rising in the cup. What was the cause? Why did it rise? What's going on?
What? So the egg is rising in the cup.
Yeah.
Right. So it's floating. There's an upward force.
Yeah. Why? What's the cause? How did that happen?
Well, we can test that, and when we test that thoroughly, we find this equation.
No,
it is simple as that.
What caused the egg to rise?
Huh?
What caused the egg to rise?
Some force. That's all you can conclude from that, right? Just by the definition of force, we conclude that force is mass times acceleration.
AB science, that is the predicted hypothesis, right? We're saying some force. So how are we going to test that force? What are you going to do to find out what is the cause of the egg rising?
Well, you change the different variables that could be a factor.
So, okay, go on, let's do it. So the egg is rising, phenomenon in nature. How are you going to test this? You're a scientist. How can I know the cause? Did somebody push it? Did it fly? Did it grow wings? How did that rise in the cup?
Well, you start playing around with some variables, right?
Well, I don't know. I only want to know what caused it. Single, independent, sole, on its own, independent, on its own. What caused it?
Well, from that observation, if you just have an egg rising, right, and you are naive, you know nothing about the world, you just see an egg rising, and the only thing you know, that force is mass times acceleration, right? The only thing you can conclude in this situation is there must be a force acting on it, right?
That's your predicted cause, a force.
No, that's your conclusion, right? Because what you're doing is you're taking an empirical first approach, right? So you're going from top down, you're going from experimental results down, and you're trying to figure out the first principles.
So your conclusion is must be, not is, because we varied and manipulated.
Well, you've just got an observation in the example you give. You have an egg, it floats to the top, right?
Yeah, how did that happen? How do you explain this? What caused that to happen?
There is a force. It's nondescript. It does not matter at this point whether you ascribe a force to it or not, right?
Is it magic? Was it magic?
Well, if we believed in magic, then we could say it's magic, but we believe in science, so we go and investigate it.
How do we rule out it wasn't magic? How do you rule it out?
Okay, so we've just got an egg, right? So we start playing with different objects, right? And we start seeing that some objects float, some objects sink.
So how do we know? I'm going to go it's magic, and you're going to say it's not magic because the cause was...
Well, we haven't really established that yet, right? So we've just seen an egg float, right?
Magic, though. It's in the realms of the unknown.
Yeah, it's in the realms of the unknown. So what do? We start repeating it. We start doing it with different objects, right? And then we start seeing some patterns emerging. We start seeing some objects float, some objects sink. Then we see some large objects that, they appear to float, but some small objects appear to sink, and some small objects appear to float. Some objects, we start trying to figure out what patterns we see, and then we say, okay, so maybe it's the size of the objects. It has something to do with that. So we start cutting down the sizes, and then we figure we can do an experiment, right? So we can control everything else, and okay, we start seeing some differoences when we cut the sizes down.
But why is this so difficult for you? If an object's on the floor and then it's on the table, like you're in the room, an object's on the floor, and now it's on the table. Like you walk out, you come back, it's on the table. Are you going to say, well, there could be some mysterious force that caused that? Or are you going to say there's one cause that could have only made that object from the floor to the table happen?
Spurs, can I just interrupt? And I don't mean to keep interrupting. It's just people have been sending some super chats with questions, and I don't want to miss them while they're in the chat. And then I'll just ask these to you, and then I'll duck out and let you carry on. The first question to you, Spurs, is from Call of the Void, and it goes a little bit like this: Yodelo ide adi oed yodeleo soz cats. What do you make of that one? I think he was trying to make me yodel.
I would respond with the yodele hoo hoo.
That's brilliant. Second one, do you know from FTFE? Do you know the speed velocity of an unladen swallow?
Yeah, I think it's about 24 miles per hour or 11 meters per second.
And the last one that we just had from JL Truth is Spurs. If the Earth is flat, then why is there an oval-shaped shadow of the Earth on the Moon during a lunar eclipse? And why has it always been that way and never been recorded differently since Aristotle's time? So why has it always been an oval-shaped shadow on the Moon during a lunar eclipse and never been anything different?
Fantastic question. Again, if we could answer that question, we would have a model. Unfortunately, at this moment, there is no flat Earth model. So a lot of these questions that you guys are asking is to help create or build a model so you guys can understand the world around you. But unfortunately, a lot of those questions are on hold, are on reserve until we, understand the surface that we live on. Is it horizontal? Is it level? Is it curved? So I think the guy, I forget his name, who asked the question. I think before he goes to the skies with the shadows and the moon, we should concentrate on what the ground is.
Okay, well that was JL Truth, and again he was a debater on this channel a couple of weeks ago. A fantastic debate. Really enjoyed that. One of the best ones we've had, and definitely worth a subscription to. I think he's got a number of channels. Definitely worth a subscription, and he's got a mention in an upcoming Conspiracy Cats video. Actually, he was still there. But he's well worth one. I'm going to pass this back to you guys. But I just have one comment, Spurs, that I've been picking up from the chat. Okay, I'm going to paraphrase it. But essentially, I think what the chat are feeling is, if you're looking at an egg, right, in water, and you put some salt in the water and you see the egg move, right, it seems that you're asking, the way that you're talking, it seems that you're asking AB Science to judge just from that observation what the mechanics of that movement are. Now, what you'll never ever see is somebody who, if an alien landed on Earth and saw a car driving down the road, just by the very observation of the car driving by the road, they can't tell you the mechanics of how that engine works. So I think what the chat are feeling is it takes something a lot more technical than putting a bit of salt in water and seeing an egg move to actually figure out what the mechanics are. And I think when AB Science is describing, the mathematics and the models to you, that's the technical side. He's not trying to dodge anything. He's answering it in the real world. Anyway, I'm going to pass it back to you guys. I'll shut up now.
Well, I just want to kind of just address what you've just said. I mean, look, this is very, very simple because when you have applied pressure, there's a force. So, I mean, the salt will press on the egg there, causing the egg to move. And then we can vary this. We can vary how much force is applied. So we can have the egg sat in the middle of the cup. We can have it sink. We can have it fall. So forces have to have a pressure. So that's why I asked about, is it a pull? Is it a push? Because obviously a force would have to apply one of these mechanisms here.
But how can you know that is the only factor?
Because that's what we experience. That's what we know. And that's why I asked you, unless it's magic, something that we don't know, something that we can't test, something that
if I take an object, right, with a different volume, I see something a little bit different. I see the rate which it sinks. I see that change. If I take an object with a different mass, I see the rate at which it sinks change as well. Right? And if I systematically test that, then I find that mass, volume, and the density of the medium are all factors. And I find this odd constant pop out, 9.81 meters per second. Whatever it is there. Right? And that is completely independent of density, right? That constant, regardless of the density of the medium or the mass of the object or the volume of the object, that constant will always pop out.
I mean, that is questionable. Whether
No. That's absolutely verified, right? I've done that experiment within, I believe, 4 sigma. Okay, it's not quite a physical discovery, but that's 4 sigma just using a fucking balance and too much time on my hands.
So you think you could show in real time in a vacuum objects falling at the same rate?
Huh? Yeah.
Okay, gives a look then.
Huh?
Gives a look. Let's see.
Well,
I mean, you probably don't have it now, but yeah, I mean, that is not. Yeah. From what I've seen the BBC with Brian Cox. That is unsatisfactory because it's in slow motion. We have cuts, we have edits, just the usual NASA. I know it's BBC, but it's just the usual cuts and edits, and not up, down the straight. And now I've seen Action Lab, where they showed objects in a vacuum. We had again time lapse for the objects fall at the same rate, so a lot of editing and cuts. And then when he showed the real time at the end in real time, we saw that they didn't fall at the same rate, and he quickly brushed over that, and the video ended. So I've seen numerous videos and examples of where the objects do not fall at the same rate. So that's not a constant. I think you should actually have a look at that again, review it, test it again, and find out for sure if that's actually a fact.
Okay, well, I've got an experiment that I can test that, and I don't even need a vacuum for it, so that's fine.
Well, if you say so, that's what I mean. Is science because you say so, or is science because there is repeatable, testable experiments?
Well, you can test it, yeah.
Because what I find is, I don't know if you know, I was speaking with their PhD, Dr. Tony Purcell, and we went through the back and forth of science and whatnot, and it appears that if you get paid to say these things, it doesn't matter if it's the truth or if it's a lie, you would get funded support to say whatever, like you're saying now. Well, just because I say so, I'll get paid for what I'm doing, and you guys essentially don't have a leg to stand on or a place at the table here, simply because for whatever reason. So that's what I'm getting from you. Is like, I say so, that's what you'll accept. This piece of paper says it's what it is. I don't have to provide you with an experiment. Accept it. Or...
I've provided you an experiment at length. I think we spent most of the past hour me trying to communicate a simple experiment on how you can test this, right? How you can test that equation. I'm sorry, but if you keep interrupting someone, right, and then don't expect them to be able to finish their explanation, because this experiment is easy, right? This experiment is primary school science, right? Seriously, it's easy.
What was your observed phenomena in this experiment?
Well, stuff sinks or stuff floats.
Okay, so what did you predict the cause was?
Well, it depends what approach you took. I mean, when I did this experiment, and
how is it an experiment if you're not giving me your predicted cause?
Well, if you can control something, if you control something, then you are predicting that is a factor in your effect.
So you're saying you controlled gravity?
No, I controlled everything else. But this is a conclusion. You don't have to, if you... I see where this is going, right? So if you make a statement, right, about something, for example, yeah, say gravity causes something to fall, and you have a formulation of that statement, and you calculate the consequences, right? And you test those consequences. You don't need to. You don't need to vary your initial thing. So you don't need to say, it's like, well, I changed gravity, right, and I can therefore show that is the cause, right? You don't have to do that. What you can do is you can say, well, if I take gravity to be a thing and it has this formulation, what are the consequences of that statement? And I can test those instead, right? Assuming that your logic is sound, then if that is correct, then if A is correct, then B should be correct, according to the logic. Now, of course, in science, it doesn't quite work that way, because you never say that, well, if A is correct, then B is correct, and you observe B, you don't actually say that A is definitely correct. You say A is likely to be correct. But yeah, that's the thing.
Okay, I mean, again, this is this position that we find ourselves in, is that you're not giving me, the sole cause to the effect. So I think that's where the problem lies. I don't think what we're asking for is very difficult. Cause and effect.
Spurs, can I just clarify what the question is? Because I'm getting a little bit confused. I know some people in the chat are. When you say you're not being given the cause, are you asking for the mechanics of how gravity works? Is that what you're asking for?
No. I want to know what caused the effect. So
yeah,
if we have
what
an effect,
caused? And I'm not going to answer your question. I just want to make sure that the question's explicit, because because it's obviously it's A, B who'll answer it. But I just want to make sure the question's explicit, because I think it's getting a little bit lost. When you say you want to know the cause of why something moved, do you want to know just that we're going to tell you, you're going to be told it's gravity, or do you want to be told the mechanics of how that force works? What do you mean? Can you define, just explain your question a little bit better? What exactly is it you're after?
Yeah, absolutely. So if we have an effect in nature, I just want to know, how did that happen? What caused that effect? So if something moves, to know, did somebody move it? Did an animal move it? Did something else move it? What was the cause to the movement of the object in nature?
So how it was physically moved. So the mechanics of the force upon the egg.
No. Why did it fall? That's the question. Why did something fall? Like I say, we've got an object, we throw it up, it came back down. Why did that happen? That's what we're trying to find out. Did it get pulled down? Did something pull it down? Did someone push it down? Going on. That's what we want to find out.
Okay, I think I'm a little bit more confused about what your question is than I was when we started. I'll be honest. I'm going to pass you back to AB Science. There's been a lot of super chats finding lately, and I would say I will definitely be asking your questions. Spurs, there's a lot of questions coming your way. I'll definitely be putting your comments and questions to him. Before I go back to AB Science, though, Ilya Moon has said something very nice about you, AB Science, which I totally agree with. She says, you are one of the most brilliant minds on Earth at the minute. Or was it on YouTube? I can't remember. I wrote down Earth. Maybe it was a Freudian. But you're brilliant. You are trying to teach and and show stuff. And she's just absorbing it all. So lots of compliments in the chat from you. But the other questions to Spurs, I'll be asking soon. I have to be closing this down in just over 20 minutes' time, because I'm going over to Sarcastic Barman's stream, which if... Sarcastic Barman is in the chat. If he wants to spam the link in the chat to that, absolutely no problem. And then hopefully I'll see some of you over at that at 10 o'clock. But for now, I'll fire you back to AB Science.
Okay, so what do you want to know? You want to know what the cause is for gravity, right?
No, not the cause for gravity. We want to know why things... Well, that's the question. How are objects staying on the Earth if it's a globe? I mean, that's pretty much what it is. If the Earth is a ball or a spherical object, how do the objects stay on the Earth? I think that's the question here. And well, we've been told Newtonian gravity, and then obviously Einstein came along and said, well, no, it's not a force, it's the bending of space-time, which again is all based on the presupposition that the Earth is a ball, right?
No, it's not.
Well, how do we know the Earth is a globe then?
Well, we can measure it.
Okay, how are you measuring the Earth?
Right. I mean, we can take several several different ways, but I think the most interesting kindergarten way is, so you will have heard of the Eratosthenes experiment, right? Hello? Are you alive?
Is he gone? Now, I've observed the phenomenon that he was speaking and now he's not. But I want to know what the cause is for that. What do you think, AB?
His mic is dead.
His mic is dead. But can that be explained using a force? He's gone.
No, his internet probably cacked out.
Hopefully he'll come back, because there were loads of questions to ask him. And there's another one in from Read by Nature as well, just come in. There were loads of questions for him. So I'm going to go through some of the comments and see what your opinions are on them. Okay. But there were loads of questions for Spurs, so I'm really sorry for anybody who's... I'm sure he'll be back. Right, let me just... does that come up on the screen that I'm waiting? Anyway, yeah, let's have a look. So, JL Truth said, made a fantastic point to Spurs' question. He said, even when we take the shadow, so when we do take the shadow evidence into account and combine it with the measurements using modern technology today, why does the model still come out spherical? Now, that was a question for Spurs, but he's got a point, doesn't he, AB?
Sorry, I'm sorry. I was trying to write. I was just trying to draw a diagram. That's when he comes back.
I've done something funky with the chat there. I'll be able to see when he comes back. Right. So JL2, if he comes back, I will put that question to him. It's a great question. Nerd Angle had a good question as well, and I was really looking forward to asking this one. Spurs, I don't know if you're out there in the chat, but what research have you done? What books, papers, how many hours, months, and years spent researching it? He makes a point. It can't just be YouTube videos that you've been watching. How many books or papers as well have you read from the dissenting side? What understanding have you got of the actual scientific side? He might come back and answer these brilliantly. We'll see. Andrew Handelsman, Catz asked Spurs if he's still prepared for that. Well, I would if I could, but I can't. Cypher Zero, I think this sums it up. Dodge, duck, dip, dive, and dodge. That's chemo all over. JL Truth again. Wow, thank you. Spurs, the mathematics of the spherical model allow us to make predictions, such as the recent viewpoints or times of comet Neowise, right down to the second. We couldn't do that on a flat Earth. And I agree, but these flat earthers seem to be happy not to have any kind of model or anything. Read by Nature, I need to scroll down a bit further for you there to see yours, and then I'll straight back to you, AB. Read by Nature asks Spurs if he's taken in anything AB has explained to him and can demonstrate an understanding of AB's points. I don't think he can demonstrate. What do you think, AB? Do you think, as pleasant as he is, and it's been nice to talk to him, do you think he's actually got when you're talking to him, do you think he understands the word you're saying?
I think he could understand it, but he's refusing to understand. My impression is that he's dodging, right? And it's an encounter. I've met him in person, and it's he's asking what he thinks is a simple question, and in fairness, it is a simple question, but the answer, it requires a minute or two to describe it for his level. Right, and then if you get constantly interrupted, then it's quite difficult, and it's a bit of a gish gallop. So I think he has the capacity to understand, but I just don't think he's willing.
I think he's in the chat now. Actually, Kraft has just said his computer crashed, and he's just getting himself back in the stream. So we'll be able to put some of those questions to him, and then, like I say, I'm heading over to Sarcastic Barman's to be on the stream there at 10. Anyone is more than welcome to join us. I think that's the thing with all flat earthers, though, isn't it? I think. In fact, I've forgotten what I was going to say. You made a good point, and then I was typing away and I missed it. Sorry, what did you say? It was a hell of a point as well.
Well, I think he has the capacity to understand, but there's got to be a willingness.
Yeah, and I find that the thing is, to understand a lot of the concepts takes. I'm not, to understand it to the level you understand it, right? It takes years and years and years. I get that. I understand that. I mean, I'll never have the understanding that you've got. But to understand sort of like the maths and the physics to like a high school level, you could do that in an afternoon. You could sit down, you could spend the afternoon really trying to get to grips with it. But that is an afternoon of essentially hard work, isn't it? And I think that's what a lot of the flat earthers, they like the sound bites. They like people saying, don't worry about astronomical observations because you can't tell anything about the Earth by looking at the sky. So then you don't have to learn geometry and you don't have to learn anything about astronomy, and it gets you out of that work. I don't know what you... Oh, there's a question here to you, actually, and both of us. This is DKK. I've no idea. What country's DKK currency, AB?
That's Denmark.
Denmark? Oh, well, so we've got 50 Denmarks. I don't know what that is, but thank you very, very much.
You get 50 Denmarks, right? I hope you've got space. I mean, it's not the biggest country, but it won't fit in your backyard, I'm sure.
Well, I'll ask his question to you in a second. AB Science says... no, you're AB Science.
Yeah.
Cy Blacklock Hughes says, well played, sir, to you, AB Science. You did very well.
Thank you,
I
sir.
thought your explanations were fantastic. And you've got that ability to break this complicated stuff down into things that even, people like me and Spurs can understand. So Morton Madsen says, don't you guys, this is to us too, don't you guys think there's a chance that most of the flat earthers or Derbers really don't believe in it themselves? It's just a claim to fame. I'll give that one to you.
Well, I think this is a complex question, right? And it's just something that I'm constantly kind of grappling with, and one of the reasons why I avoid a certain type of video, right? Because within the flat Earth community, you've got grifters and you've got victims.
Yeah.
Right. And I want to try and figure out. I want to be, if I were to go after a person, I want to be damn sure that they're a grifter and not a victim.
Yeah, definitely.
And it can be hard to tell it apart, right? Because you really, in a lot of cases, you really need to study grifters and really get to grips with how grifters operate.
I think I'm not going to name names here. I think everyone knows who I think is the biggest culprit for that on there. But I think some of the big names out there, some that I might used to have used a lot that I don't use anymore. I've come to realise that they are in that victim category, but they are making victims out of other people because they've achieved a certain channel size or status or whatever, and it is that way, and you can hear. Like when Spurs was talking tonight, and I'm not bad-mouthing him, I'm sure he's in the chat listening, he was using comments and phrases that you can hear the flat earthers he's picked those things up from, Well,
yeah, you can see this, and I think that's a good kind of litmus test. I mean, it requires a bit of know-how, but you can... you can ask a flat earther to... No, I'm not going to use flat earthers, right? Because I've been dealing with the electric universe and specifically Ken Wheeler's adherents, right? And I've been dealing with them a lot. And I asked them to explain what they mean, and they will come out with verbatim the same thing. And one of the key litmus tests that you can apply is, can they describe it in their own words in several different ways?
Yeah.
And that's important, right? Because are you just remembering that this is the line and this is what, do you understand it or not?
Spurs is back, but you're right. If you can if you can explain something properly, you know, at different levels to different people, you understand it, you know, and rather than just saying the same thing, you know, the same quote and then getting confused, you know, like being. You know. But Spurs is joining now. I do want to put some of those questions to him from this because people have I've contributed to ask those. So do you mind if I start off with those, and then we can get back into the debate? And then when it gets to about 9:45, maybe, so 20 minutes, we'll shut everything down and I'll head over to Sarcastic Barman's stream, which Crafty Keel has been linking in the chat. She's not been leaking in the chat; she's been linking it in the chat. Then anyone can go and watch it and subscribe to Sarcastic Barman as well. So says he's still joining. I thought he was here by now. I've admitted him, and he says he's joining. Anyway, when he does join, I'll ask those questions. So who have we got in the chat? We have Seek Truth, Speak Truth. I've seen Jose. Boom. Hello, Jose. We've seen Global Mo. Wolfgang. You know, I'm just going to sit here and read all the names out in the chat. Anyone you want to say hello to in the chat there, AB?
Well, we've got Blacklock Hughes. We've got Tatty.
Tatty's here.
Presumably very drunk. Well, yeah, of course, we've got Crafty Killer, and who else have we got? I'm going to pull up. We've got lots of people. We got the Ever Silly Tusk, and
we've got Spurs back.
Jesus, that's a big list.
Sorry about that. I mean, I don't know.
That's right.
My PC just crashed and died right in the middle of that.
But what was the cause?
I think it was overheating, actually, probably.
But I don't know what happened. I wonder what the cause was.
Yeah, the heat, the temperature.
How do you test it?
Yeah.
Just pulling your piston out.
I stuck it in the fridge freezer. It cooled down, and it's good to go.
Yeah, but how do you know that it's not actually the fridge freezer that powers it up or something?
What was your independent variable?
The independent variable was the temperature, the heat, the source, the heat.
Is it?
Source.
But what is heat? Anyway, we could do that all week. That's
Yeah.
You've been a show there about how people, I'll be honest, Spurs, how people like Nathan Oakley and Quantum Eraser spin this stuff out for a long time. They're not interested, I'll be honest. They're not interested in the debate, but they can spin the most simple things out for so long, asking questions like that. Anyway, there are some questions for you, which I'm going to fire to you before I put you back to AB. Right.
You got way more questions than I did.
You did. JL Truth asked you a question before. Are you still there, Spurs?
Yeah. Can you hear me okay? Yeah.
Yeah, he asked you a question before about the oval shadow on the moon and why it's always been oval and it's never changed, and you give an answer. I can't remember exactly what it was, but his response to that was, so when we take shadow evidence and we combine it with measurements using modern technology today, why does the model still come out spherical? What's your answer to that?
Yeah, I mean, it can be quite deceiving. So if we apply a method, we can probably, get results that we're looking for. But, if you practically test these things, you'll find that you'll get a different answer. So I think that's where, we have to kind of meet in the middle here and decide, well, you've got the numbers, we've got the idea for the practical demonstrations. If we could, make them meet, and then obviously you could find out what the actual answer is.
Okay. So that kind of suggests you're saying that the modern technology has just been sort of like made up and not, and proper tests haven't taken place, proper observations haven't taken place, proper modelling hasn't taken place.
Yeah, what I think is because in the old world they thought it was a flat Earth, and so there was an idea. Well, look, ships are going over the horizon here. It looks like they're going over. It looks like curvature. So obviously, I think people set out trying to explain this. So they came up with a system and that fits their observation. So that's the problem with having the hypothesis first, you see. So yeah, I think what all that's happened is what AB has done, and what you're saying is that you have an idea, you build everything off the back of that, and you're saying all the technology supports a globe, but it doesn't really. I mean, globe technology would be uncut evidence of going around the globe 24 hours. You wouldn't need to, edit out the parts that we're looking
We'd need
for.
something like, a space station orbiting the Earth or something like that with a live stream, wouldn't we? I suppose.
Yeah.
But I'll have to move on to the next question because there are a few. There are a few for you, Spurs. This one's from Nerd Angle, and he says, "Spurs, what research have you done? What books, papers, how many hours, months, and years spent researching? It can't just be YouTube videos. How many books or papers have you read from the dissenting side?" So.
Absolutely, yeah. So obviously, around 6-7 years ago, I got into it. So I set out about doing research. So that means to me is looking at what they tell us and going out into the real world and testing that, whether that be with lasers, whether that be with cameras, whether that be with measuring tools, and just basically finding out if the Earth is actually curving like they tell us. So, I mean, anyone can do this. You can go out and find out if the water is horizontal, if it's level, if it's flat. So, I mean, yeah, I've been out with Ranty, I've been out with Nathan, I've been out with Anthony, I've been out with, several flat earthers with boats. Like
the A-team of flat earthers.
Something
like the A-team. I'm sorry to rush you through these, but there are quite a few, you see.
Sorry, I've just got a quick question. How do you know what they tell you?
It's not what they tell, it's what I've actually done personally myself. So like I say,
you're saying you're comparing it to, because you say you figure out what they tell us, right?
Yeah.
And then you compare observations to that. How do you know what they are telling you?
Well, that's just it. I mean, we don't know.
But can you tell me? Can you tell me, for example, what they say about what they say about gravity, right? What's the formulation for it? What do they tell us about how we arrived to the conclusion that is Newton's universal law of gravitation, right? What led to that, and what experiments have we done to show that is, at least within a limited case, correct?
I don't quite. So, I mean, what's the question here? What are you asking me?
How do you know that, right? And can you give detail about that?
Okay, so like I said, so we're told certain things because we have a level of trust. Like, I trust you. If you tell me there's gravity, if you tell me the Earth is curving, I will trust you. I have no reason to doubt you. I say, okay, there's gravity, there's a force. Okay, so so I have to test this now. I'll go out there and I'll be like, okay, the scientists say there's a force. Let me go out and see if I can repeat what they say. So they'll say the Earth has a radius of 3959. I said, okay, let me go out there and see if I can test this for myself. So what we find is gravity that they tell us is the force is not a force. It's not even a thing. It doesn't do anything. It doesn't have any energy. It doesn't cause work. We find that the Earth is not curving. Water is horizontal. There's no vertical.
So I've got a question. What is work?
So obviously the idea is that work is energy. It's doing something, and gravity doesn't do anything.
Can you give me a formulation of work?
No, I'm not a mathematician, but when we're talking practice,
right? So that because that is the key point, right? Because in science, there are some aspects which are very key. Right? Good science has to be quantifiable. It has to be testable, right? But yeah, it has to be quantifiable. So you can perform your measurements and quantitatively compare that against prediction. Right? So if you don't understand the maths behind it, how are you going to compare your measurements against the theory?
Because I'm using practical variables here, things that I can touch, test, and manipulate. So your concept, I can't really, manipulate what you think, and what you're thinking of is a mathematical equation. So when I try to apply your conclusion, all I'm testing is your conclusion. That's repeatable, the outcome. So you're saying the outcome of my equation is there's a force and that the Earth is curving. The Earth has curvature to it. So obviously,
I'd like to see the equation that describes both, but yeah.
No, but what I'm saying is that we're told, you asked us who tells us. So people like yourself tell us the Earth is curving because we've been able to calculate with the angles and the distances, and now the Earth is a ball. And also with that, we can give you the calculation for this gravitational force. Now, all I want is the conclusion.
Yeah, okay, so here's a conclusion, right? If the Earth is spherical, right, the angle of the sun at noon on the equinox, right, let's say at GMT, right, the angle of the sun as a function of latitude in the northern hemisphere, right, follows that blue line.
Yeah.
Right? And that's our conclusion from that model, right?
Okay.
The conclusion from a flat model is that it would follow that red line.
Yeah.
Right? But the black crosses are observations. So from this data set, can you conclude that the Earth is flat?
So what you've got here is your presupposition and your answer inside the presupposition. So you can't presuppose either. You have to go out there and actually practically measure it.
What have I presupposed?
The Earth being flat or a globe?
Huh? Well, that's my initial statement, right? Okay, so that's my starting point.
That shouldn't be your starting point.
Huh? Why not?
Because that's not science.
Well, yeah, it's perfectly fine.
No, again...
Are you the arbiter of what science is? What is science?
So science is the study of the natural physical world through observation and experiment.
Yeah, okay. So how is that not conform with science?
Because you don't have an observed phenomenon here.
Oh yeah, the angle of the sun at noon on the equinox changes depending on my, on my latitude.
That's not an observed phenomenon.
Yeah, it is.
Can I just make this a little
Bit
simpler?
Okay, let's go back to the super chats because
I will get to those, but I just want to ask Spurs a question to bring things to a simple. I think to something that's going to demonstrate the point AB is trying to make. Spurs, if I give you a football, you can see that football, or a basketball for anyone in America, you can see that that's a sphere. Yeah, you can see that there's curvature. Yeah. Okay. How would you measure the curvature on a basketball?
You would.
How would you measure it? What measurements would you take? Because once you can tell us how you would measure the curvature on a basketball and the techniques you would use to measure the curvature and give me a calculatable curvature, then we can start talking about how you might do that on something larger like the Earth. So I'll ask some more super chat questions. You can think about that, but then at the end, if you can tell us how you would physically measure the curvature on a basketball. Because what I get frustrated, a lot of flat earthers will ask the question, show me calculatable or measurable curvature of the Earth, but actually they can't answer the question I've just asked you, which is how would you measure the curvature on something that's obviously a sphere like a ball. But I'll come back to that later on. I'm not going to jump on you with that right now, but I'll ask some of the other super chat questions. So we were up to...
no, I mean I can answer that now. I mean you can determine.
Go on, yeah.
Yeah, you can determine the degree of any curve by finding the circumference of a circle. You multiply the radius of any circle by pi, and a numerical constant that begins with 3.142, which represents the relation between the circle's diameter and to its circumference. So you just multiply that by 2. But I'm not a mathematician.
I don't know. You just invented a fantastic bit of maths there.
I mean, I think you're just looking for like the radius of a circle here.
Okay, so I've just got a question, right? Because a lot of flat earthers then talk about curvature. Can you define what curvature is?
So you want the definition of curvature?
Yeah. Without googling it, please.
Well, yeah. I mean, it doesn't need to be Google. I think we all know what the definition of curvature is. Obviously. when we have a curve, it's just it's where we have a deviation from a straight line.
Talking about curvature.
Curvature, yeah. So it would, like I just said, it would be a gradual deviation from a straight line.
Okay, so curvature
Mm-hmm.
is a very specific figure, and it's a very specific property of a line that is curved. It is 1 over the radius of curvature, right?
Sure.
And for a sphere, we'll be talking about a Gaussian curvature, where we're dealing with 1 over the equatorial radius multiplied by 1 over the polar radius. Right, there's a very specific definition for what curvature is.
Yeah, but I
and
just
has
told
very
you
specific units.
Yeah, but the definition is just the degree in which it deviates from a straight line. That's what curvature. So we're looking at the horizontal, a straight line we can use, for example. And then if we want to know how much that straight line is curving, we would look at the quantity, the numerical quantity expressing curvature, which would be how many degrees, yes, from a straight line, as I said initially.
Not quite. The proper definition is 1 over the radius, right?
Yeah. Spurs.
That is the definition, right? Because we're not talking about phenomenological stuff. We're talking about definitions here.
Is it because you've said so, because you get paid to do science, or is that the actual definition that we can
Because I
find
get
online?
paid to do science.
No, because I understand that because scientists get paid by institutions, they can pretty much say whatever they like, right? Without
Okay, sorry, because this is a little bit of a bone I have to pick with people about this. How much do you think a scientist gets paid? Just an average scientist. You know, how much in the UK do you think their annual salary is?
If you ask Dr. Anthony Purcell, he gets paid handsomely. Now, handsomely could be hundreds of thousands. It could be millions.
Yeah, but is he the average scientist?
Well, I mean, I think if you're a scientist, if you do stuff for institutions, they'll pay you handsomely, as Dr. Anthony Purcell told us. You know, and he can pretty much tell us whatever he likes. Like you're saying to me, well, you know, this is what I say. I'm the scientist. I'm the one who is out there doing things at universities and institutions. And you're not actually saying, well, look, here's the demonstration of the force. Here's the actual curvature of the Earth. You're just saying, look, here's a piece of paper. Believe it or not, because I'm the guy who gets paid.
Seriously, if you weren't interrupting me for most of the show, I would have explained to you in a very simple and concise way how you can test what I showed on that bit of paper. And that's the key to science, because when we undergo our training, we get told things, and then every physicist will test them. Right? It's simple as that.
But you're saying that because there's more than one cause, you still haven't told me how you've tested it. You're saying there are multiple causes to why.
I have tried to explain that. I've spent, I think it was 40 or 50 minutes trying to explain that to you, but due to interruptions,
you said there are many reasons to why the egg rose. You said I have an equation that says it's gravity whether you like it or not.
Well, no, actually, I didn't say that. I just said that there was a downward acceleration of 9.81 meters per second. That's completely independent of density, right?
Whether you like
and
it or
mass
not.
and velocity,
Where's
whether
the
you
evidence?
like it or not, because that's what the experiment shows.
Yeah, but where is the evidence for this? You're saying to me whether you like it or not, this is the rate, and I've just told you that Brian Cox edited his ball and feather. I've just told you that Action Lab edited their ball and feather. So there are no observations anywhere in real time without the effect of a human. Well, obviously you've got to release the objects. I don't mean that. I just mean without them holding the vacuum.
Okay, here's an experiment you can do, right? Simple experiment you can do. You can take two balls which have an equal size, right? And they have different masses or different and therefore different densities. Right? You take a ramp at some angle and you hold them both at the top of that ramp, and you let go at the same time.
Okay.
Right? An equivalent statement of all of this would be that those balls would reach the bottom of the ramp at the same time. I mean, there's experimental error, but you have to understand.
That's not an experiment, by the way. That's not an experiment.
Yes, it is.
What was your observed phenomenon?
Stuff falling at the same time, at the same rate.
Where did you see that in nature?
Well, we can predict that. We've observed that roughly.
Where did you observe that?
We see stuff falling, right?
Yeah, but not at the same time, right?
Well, that doesn't even matter. Even if they're falling at different rates, we can investigate why that is. Is that to do with their mass, their volume, their density? What is it?
Yeah, but I'm just telling you that's not science. That's not an experiment because you didn't observe that in nature. You already presupposed something and said, I'm going to go with my prediction.
I think you need to scratch up on what an experiment is, and I think you really need to scratch up on the different methods.
Yeah, but AB science, I'm not trying to make an argument. If it's because you said so, and that's just the way it is, there's nothing I can do about this. Right? I'm just a guy, regular guy. You are the scientist. You get paid for this. Whether I like it or not, this is what you will tell us. I can't do anything about that. So all I can do
can test it. I've just given you a means to test it.
No, but I've just told you we don't see that in nature, so I don't need to test that.
Okay, so
suppose you
don't like it, you don't have to test it. Okay, great. That's okay.
Yeah, I'm going to have to go back to the super chats, but Spurs, I think AB Science is a professional scientist. I'm a science teacher, and I will just have the last word on this bit that. What you hear coming out of Quantum Eraser's mouth and Nathan Oakley's mouth that you've hopped on board with, the whole independent, dependent variable thing, is the way that we teach science to 11-year-old children. And then from that point, and well done to Nathan Oakley and well done to Quantum Eraser for grasping how we explain it to 11-year-old children. I'm well done to those, well done. But from that point, things do get more complicated. And if you're going to hold on to such very strict, myopic definitions of what science is and isn't, how can I put you're never going to have an understanding of anything. We could apply. Well, I don't think I've said what I need to say, but we need to get onto these super chat questions because there's loads here for you, Spurs. So, and I'm due on Sarcastic Barman's in just over 10 minutes, so we can fly through the questions quick. Andrew Handelsman says, Spurs, are you prepared for that?
For what? Sorry.
It's just a phrase. I'm not prepared for that, Kent Hovind. So he's asked me, have you been prepared? Yes. Obviously, you don't follow my channel. That fills me with...
No, I do actually. I do watch your stuff constantly. Yeah, it's very good.
Yeah, the Kent Hovind. I'm not prepared for that stuff on Baldy Catz.
Okay.
Cypher Zero says, dodge, duck, dip, and dive and dodge. That's chemo. Sorry, Spurs. That come from Cypher. JL Truth again. Thank you very much. Says the mathematics of the spherical model allow us to make predictions. Oh, have I read that? Oh, yeah, I read that when you weren't there. So the mathematics of the spherical model allows us to make predictions such as the recent viewpoints and times of the comet Neowise down to the very second. We couldn't do that on a flat Earth, and the fact that we can make these predictions down to the second, surely that tells you something, no?
I mean, again, these equations, they could be useful if they're used in the right way. It just seems to me you guys have used your power for, for the wrong reasons. I mean, we know water doesn't conform around the exterior of an object. This is why we're talking about the force. You need that
Why
force.
would it? Why would water conform around what? Like if I pour water on a football, why would it?
No, not like that. So you've got the mass, large body of mass. Because you have so much mass, it should pull other objects towards the center of that. So obviously, if you pour it on a basketball, the water is going to fall towards the earth where the larger mass is.
Yeah, brilliant, you got it. Next one is from Read by Nature. Ask Spurs, have you taken in anything that AB has explained to you, and can you demonstrate that you understand AB's points?
Yeah, absolutely. I mean, he's given us the equations of why gravity is a force, which is understandable. But for me, it's all based on presupposition. So the equations, the idea that he has, I get it, I understand it. All I'm asking it is for a actual practical demonstration, not that I can do, that he can back up and present and show.
Okay, but if that involves, I'm assuming if that involves actually anything to do with even filming the curvature of the Earth, that like from space, for example, that's not something you're willing to accept.
Yeah, if he could film it from space for himself, I would definitely. I mean, again, I trust AB Science. I mean, if he went up and said, "Hey, look, I'm going up. This is the curvature of the Earth." Again, he has no reason to lie, but institutions and agencies do. That's where you're confusing things here, Kat. It's not the person. It's not that we just distrust. It's that the agencies have an agenda. Yeah.
I'm sure AB will have something to say for that in a minute. We really are on the minutes, though. I will go back to him in a second. We've answered that one to us. Side Blacklock Hughes says, again, he said, well done, AB. Daybreaker Flint says, Team Drac, AB Science, good work. But he spelt that in foreign, so maybe that's your language. Oh, you're muted there, AB. I can't hear you.
Yeah, okay, I'm there. Yeah, that's Team Drac. It's a Dutch word for dragon.
Do you like the way I said he spelt it in foreign? Because I didn't know what the language was.
He spelled it in foreign.
Spelt it in foreign. Creaky Blinder, don't know who that guy is. He says he really, really has a... I think he's being sarcastic, Spurs, don't take this to heart. A thorough dislike for flat earthers. Call of the Void. This is... I think this is... We're up to speed now. Call of the Void. What force, Spurs, makes the sun rotate around the flat earth?
Good question. We don't know what the sun is. You know the.
Would you say there is a force?
Power in the sun. Again, I would be. It wouldn't be wise to answer that question. I mean, I really wouldn't. I don't know.
But it does move, doesn't it?
It does move. It does move.
So what? Okay. So, but would you say that something that moves requires a force to move it?
Yeah, I mean, again, if something's powering the sun, sorry, and the moon, yeah, something definitely powering these objects. What we simply don't know.
Okay, could be
what?
Could be something like gravity, couldn't it? I suppose maybe. But I'm going to pass this over to AB. I've got a feeling that I've got a link waiting in my inbox to click on soon. So listen, guys, both of you, thank you very much for coming on here tonight. It's been really nice to hear both of you speak. I know you've come from very different angles with very different experiences, and it's been brilliant to.
I just want your opinion, Kat, quickly. I mean, do you think we're crazy? Do you think we are? I mean, I want your full, honest opinion.
I'll give you my full, honest opinion.
Are we nuts? Are we? I mean, is it rational to question something we've been told, and then when we come up with a conclusion, we're saying, well, it's not right. So, how do you view? Yeah.
I think my full honest opinion that I'm going to give AB Science the last word just to bow out on. But my opinion is that you are victims of people on YouTube or people in real life who have said things that resonate with you because some things in the world are counterintuitive. Some things are counterintuitive. You know, you look at water and it does find its level, and then that's counterintuitive to what you might think of on a bigger scale. And I think with a low level of mathematical understanding, a low level of scientific understanding, and a lack of real ambition to gain the understanding and the education in those areas means that you rely on people out there with strong personalities like Nathan Oakley, Quantum Eraser, who say stuff and you can buy into that and then think, you know what, I don't need to learn the astronomy because Nathan's already debunked space. You know, I don't need to learn about gravity because Quantum Eraser's already debunked gravity, or Nathan or Anthony Riley has. So I don't think you're crazy. I think it's a mixture of, and I'm sorry to say this, but I think it's a mixture of laziness and lack of academic ability, and the two, you know, and just wanting to believe in something a little bit special. So I'm sorry about that. That's not personal.
It's fine, but I mean, people do have the. I mean, I do understand that because Nathan's been on it for a long while. It can seem like, you know, he's giving out the information, but you know, I have been in the circuit. Before Nathan there was discussing, before Mark Sargents, before Jaron, before Globebuster. So I understood that this is not a globe. before it was as popular as we're seeing it now. So I think these arguments have been around for a very long time. It's just taking the confidence, people actually asking them and putting them forward without the ridicule, because it's taken a hit in the first couple of years. And I think now today we can talk about it. It's still ridiculed, but it's out in the open now. So I would like to have a show where we talk about the psychology of it all. So where you have time.
Well, let's book you in and do that, because I genuinely have to go soon, and there's two more super chats that I didn't read out, and then I'm going to pass over to AB. But you're more than welcome back on again anytime, Spurs. Tommy Gronvold, why can't Spurs answer anything? I think that is a bit of a feeling in the chat.
I'll let you do the chats. I'll be back in a sec. Okay.
Oh, well, this is the last one. I'm done. Mark. But obviously, if you need to go, go. He doesn't have a question. He just wants to support the channel. So thank you very much for that, Mark. Right.
Thank you very much, Catz. Under no pressure, my channel. Check it out. Stay debate.
Spurs, we'll link your channel in the description. You're more than welcome back on anytime. It's nice to have someone come on and actually not be screaming and shouting over anybody, on the flatter. So, thank you for that. And I don't think I've got your email, but if you drop us an email, we can sort something else if you want to come back on in future.
Fantastic. Thank you very much, guys.
Thank you very much.
Thank you much for your time. These questions of science are very important for the world to try and find out what's going on. So with that, I'll catch you there next time.
All right. See you later. Ta-da. Thanks.
Ta-da.
To everyone else in the chat, just while AB Science comes back, I'll give him the last word. Again, I'm going over to Sarcastic Barman's stream. I'll be on his pub chat in about 5 minutes' time. So Crafty Keeler's just linked it in there. If anyone wants to come over and sub to Sarcastic Barman, he's well worth it. AB, you've got 4.5 minutes before I've got to go, just to say anything that you might have wanted to say in the stream.
No, that was just going to be a tiny little nitpick, but I'm just going to leave it at that and give you time to have a quick breath and switch over to Barman.
Well, thanks for being on. And honestly, I meant what I said before. I know you've helped me out a lot with physics stuff in the past, and I know your knowledge is something that I'll never, I'll just never get there with it. But the way you can break it down and make it simple for people and have conversations like that, I think it's really, really impressive, And if anyone's not subbed to AB Science, I'm pretty sure everybody is. But if anybody's not, get over there and hit that subscribe button, because it's a truly unique channel, I think, in this community, really.
It is funny because the way I go about it, it's quite simple, right? I didn't formally learn physics at first, right? Up until university level, I was completely self-taught in maths and physics, right? I wasn't allowed to do the higher level maths at school, which allowed me to study maths at a highly selective college. I failed my GCSE physics. And I was self-taught, and I think that gives me a different approach, because I had to go and really think and try and make sense of it in my head, and that's what my channel is for, right? It's for people who didn't study at university and had that curiosity and wanted to figure this stuff out, and want to do it in an informal capacity, because I never planned to study physics, right? I worked in business. I was a management consultant, and I was making very good money, but I was bored of it. I hated it, and so I jacked it in, and I thought, I started developing this growing passion for physics, and that's why I ended up doing it, because I felt the only place a misfit like me would fit in is in the science department.
Mate, I'm jealous. I'd love to be doing what you're doing, and I'd love to talk to you about it more, but I genuinely am 2 minutes away. And
Gotta go.
Click on this link. So, listen, everybody, thank you so much for watching, and all your support, and thank you to everybody who's super chatting as well. That's always extremely generous of you. So, thank you to everybody. I'm going to close this down now, and we will see you next week when I am debating draft science on Wednesday on this channel. Yeah, I know. I'll be picking your brain about that. Bye-bye, everybody.
Good night.
Oh, how do I end this? Right.